Okay, let's just talk a little bit about biogas in South Africa. I mean, if it's such a fantastic, I mean, that's a typical question I get. And please, guys, if you've got any questions as I go along, I can talk, quite fast and get quite enthusiastic. But please stop me at every point in time. If you don't understand, if you want a question, please feel free. I've got no problem with stopping me and asking questions along the way. But if biogas is such a fantastic system, which it is, why don't we see more? Why haven't we seen more digesters in South Africa? And if you talk numbers-wise, we probably got around about 400 digesters in total installed in South Africa. That's now commercial digesters, rural digesters, small-scale digesters, as well as commercial digesters. Probably the majority, or half of them, was installed at municipal wastewater treatment works in the 1970s and the 1980s. Going back to what I said before, that we actually were driving, we were leaders as far as biogas concerned. The reason why it was so popular at wastewater treatment works is that it, first of all, because it removes the anaerobic process, removes pathogens, it improves the quality and the environmental impact of sewage sludge at the wastewater treatment works, which is the biggest challenge at wastewater treatment works. They can get the water, extract the water, clean the water, but they're left with a sludge, which becomes a major big problem. So the digesters were installed at our municipalities specifically to reduce the pathogen content of the sludge, as well as the volume of digester that they need to get rid of at the end of the day. The other probably 90%, that's about 50% of what has been installed of the 400 odd that's been installed in South Africa. Nobody knows exactly how many, but that's probably a close enough figure. The other half was installed as rural digesters, mainly with grant funding, in rural communities, clinics, schools, and that kind of thing. Some of them are still working, some of them are not working. For various reasons, mainly because of maintenance and the type of digesters we've that was built, and we'll talk a bit about that as well later. But if you compare that to a country like China, I mean, we talk about we've got 400. China's got 17 million digesters. India's got 12 million digesters. I mean, Lesotho, next door to us, they're not exactly a big country, they've got 600 digesters. So there's a massive, massive big potential for biogas to be developed as a viable, sustainable, making a lot of sense type of technology in South Africa. The Germans are the leaders. They got about 7,000 large-scale commercial digesters up and running in Germany at the moment. It's sort of reached a plateau, and it's dropping down quite considerably. So we've got a lot of interest from European biogas companies looking at the potential in South Africa. But at one point in time, I mean, they were building, one commercial digester every 8 hours because they're building about, 1,000 digesters a year. There are many other European countries that's also quite advanced and makes use of biogas. But, this is just interesting to see, there's a massive big potential in South Africa. And putting small digesters into areas where people can see it, like that Cummins is doing, that's brilliant. From an association point of view, from a biogas enthusiast's point of view, that's the kind of projects that we need to get out there, that our kids start knowing and can see practically how biogas works, so that they can, say, wow, that makes a lot of sense, and get them involved in bringing, their food waste from the house to the school, chuck it into the digester, and they know that their lunch that they're eating tomorrow afternoon is made on the food waste that they put into the digester. So that's where we need to support, and the work that you guys are doing with the schools is absolutely brilliant, and we applaud you guys for it. Here's an interesting, I mentioned that in the, way back, we had digesters in South Africa. This is a chap here, you can Google him, John Fry. He's seen as one of the pioneers of the early commercial digesters. And he had a pig farm, and he started with a very, very simple system. It's, as you can see, it's just two 45-gallon drums. The top drum actually sinks into the liquid of the bottom drum, and that way it seals it so that there's no gas escapes. And as the gas is generated, it's simply the top drum starts floating. Very crude, but it worked. I mean, he ran his Lister 6 horsepower Lister engine for about 4 years, or 3 or 4 years, on biogas. Interesting enough, the main reason why he started experimenting with biogas is because of his neighbors. They complained because of the smell of his pig farm. That's how he started with biogas. And eventually, Eventually, as I said, he made very good use of his of his manure to generate electricity, and it solved primarily or largely solved his smell problem as well. And where was this? In the Farmers Weekly in South Africa in 1957. That's where this article appeared. So in the 1950s, again, we were, as I mentioned earlier on, we were the leaders in biogas, or initiated the technology or the practical application of biogas in the world. Eventually, he didn't get the support, and he went to the UK, tried his luck there, eventually ended up in America, where he passed away. So yeah, so the technology was lost. I could have made the speech in 1957 if everybody listened to what old John Fry was saying. Okay, now let's just talk a little bit about what can you put into a digester. So typically, whatever you can eat can go into a digester. So any material that can be digested by your digestive system would be ideal to go into, with one or two exceptions. A digester doesn't like too much acidity because it likes to be maintained at a neutral pH. So too many orange peels and stuff will affect the digester. But in essence, anything that you can chuck on a compost heap or that you could eat or could potentially digest. I mean, you're not going to eat manure, but you will be able to digest manure. But the digestive system would be able to deal with it. So, so as I said, in wastewater treatment works, we had a lot of work done in the early 1970s or the late 1970s and 80s on waste, on sewage waste. We've actually got one of the most modern and recent projects, commercial big 1.2 megawatt installation, was done here at the Johannesburg Sewage Works, Joburg Northern Works sewage plant. They had digesters there that dates back to the 1980s. They refurbed the digesters, and about 2 years ago they put out a tender for somebody to utilize the biogas to generate electricity. It was very successfully done by a company called WEC Projects. You can go to their website, it's actually quite impressive. And they're very neat installation. They're running for 3 400 kilowatt, not Cummins, but Guascor generators. And they're feeding in 1.2 megawatt into the actual grid of the wastewater treatment works. But you can apply it anywhere where there's sewage. You can replace your existing sewage system if you're on a small holding like myself. That's how I started with biogas, by the way. About 5 years ago, my septic tank system on my small holding here in Muldersdrift was saturated, was starting to push out of the ground. And I knew of biogas, and I tried to find somebody in South Africa that could build me a digester, instead of building a new septic tank, build me a biogas digester. And I couldn't find anybody in South Africa. Eventually found a company down in Cape Town that wanted to charge me R250,000 to build a digester. So I said, nah, I want to build a digester, not a new house. So, so that's how I started. And it runs, I'll show you some photographs of that a bit later on, but it runs on sewage, primarily on the sewage from our household that goes in there. Just that we were talking about what type of material goes into your digester. Just to expand on that, when you've got a small digester like myself on a small holding that gets fed primarily from the sewage, you want only the water coming from your toilets going into your digester, not the water coming from your washing machines and your showers, for two reasons. The one is, my most important reason is the fact that in your wastewater is all the chemicals, all your soaps and detergents and cleaning materials. Those chemicals will kill your microbes in your system. So you don't want that in there. We use only biodegradable stuff, but still I separate the two. We got our grey water going directly to our wetlands, and we got the water coming from the toilets, because at the end of the day, what you want to do is you want to feed your microbes, and it's in the solids in your waste, in your toilet water that produces the solids that the microbes then will live on. But you can supplement it then with anything else. When we put kitchen waste in there, we got some manure from the horse stables next to us, etc., etc. The more waste you put into it, that's a very important factor to remember as well. The quantity of biogas that you're going to produce at the end of the day is directly proportionate to the type and the quantity of material, organic waste material, that you've got available to feed into it. So I get the phone call from Greenies in Sandton that say, ooh, well, we've heard about biogas. We've got an 800 square meter house. We're 3 people in the house. Can we go off the grid with biogas? No, you can't. Because you only produce a limited quantity of organic waste that can potentially go into your digester. And in their case, with a bit of lawn clippings and kitchen waste, they will probably be able to produce about 20 minutes worth of cooking time on a biogas stove. That's it. So the quantity of biogas that you're going to produce, as I say, is a very important factor to remember. The more feedstock you've got and the higher fatty content, the more calorific value your material have, the more biogas you will produce. For instance, from a ton of, let's call it cow manure, from a ton of cow manure, you can possibly generate about 80 cubic meters of biogas. From a ton of fatty kitchen waste, you can probably generate about 800 cubic meters of biogas. So it very much depends on what type of material you got available to feed into it. Kitchen waste from a kitchen is typically a very good feedstock. You can't start your digestion process purely on the kitchen waste because there's no microbes in it. You got to start you got to inoculate your system with either with bought microbes, but that in 99% of the times what you do is you start it with either the digestate from another digester to inoculate it. Same way that they do in septic tank systems. When you put in a new septic tank system on your farm or whatever, you throw a dead animal in there. That produces or provides the initial microbes that will then multiply in your system. Or what we do in most of the cases, we just get fresh cow manure. You mix it with water. The cow's got 4 stomachs. So by the time that the manure is produced out on the other side, the microbial action is already well on its way. And you inoculate your system, and then slowly but surely you will start feeding your digester then with whatever material you've got available. So yeah, if we go back just to what type of waste, sewage waste we spoke about, and that can be, in schools and hotels, anywhere where there's you've got access to sewage. But remember that just as long as one remembers that you want only your sewage waste going in there, not your grey water. There's no reason why you can't join your digestate that comes out of your digester, join that with your grey water, and then use that for irrigation purposes. Food waste, and there's a lot of food waste. I've got there's a hotel that I'm doing at the moment. They're producing a ton of kitchen waste a day. Waste. So, we can replace, they use about 50 kgs of LPG gas a day. We can replace about 60% of that with biogas by just converting their waste. Yes?
I just wanted to ask you,
sure.
This waste
you don't add anything to the system. Once, and you can purely measure, you in a large commercial installation, you will always monitor your temperature and your acidity level, your pH level. Because that's one thing I haven't mentioned. It's good that you asked the question because it reminded me of it. It's the microbes that produces or is responsible for the digestion process. Optimally, they work at body temperature, 37 degrees. So if you can raise your temperature of your digester to 37 degrees, you're going to have optimal functionality of your microbes. They're going to produce as much biogas as they potentially can. The lower the temperature, your biogas yield will drop down. So that's one thing you control. The other thing is you control is your acidity level. You want to, between 6.8 and 7.2, you want to maintain your acidity level or your pH level. If it drops down, they said you can add alkaline to it. You can play around with what you can do, but you've got to monitor the system in at the breweries. If it goes out of Kildare, because their process runs 24/7, and the digestion is very quickly. And a normal digester, you require a certain time period for the process place. So we're talking anything between. Talking about a retention time, anything between 15 to 50 days, depending on what type of material you've got in there. So if you've got a material that digests very quickly, maintaining the acidity level is critical because you've got to catch it very quickly. Otherwise, your whole system acidifies, and you've got to shut it down. All the microbes are killed. So, but you don't add, as a rule, you don't have to add anything to the system. Once the microbial a family or the number of microbes as established in themselves, as long as you feed them, they will do their job. Just going back on the retention time, that's also very much dependent on the type of material that you've got. Grass, for instance, need about 60 days. Depends also on whether your system is heated or not, about 60 days, but whereas fatty material will take 4 or 5 days to digest. So I mentioned that your quantity of biogas that you can produce is dependent on the quantity and the quality of the material, but it's also another factor, apart from the temperature that I also mentioned, is the size of your digester. Your size of your digester will be determined by the quantity, also by the quantity and the quality of the material that you've got available typically. And so if you've got material that typically will digest in 20 days, you use that to determine the size of your digester as well. Because you don't want the material to process or progress through your digester before it's been fully decomposed, because then you're going to get undigested material coming out on the other side. If you've got a bigger digester than the quantity of material you've got available, it just stays in the digester a little bit longer, so that's not so critical. As long as the quantity of material that you feed into digester doesn't get so low that your microbes start starving and they kill. If you go away for holiday for 6 weeks, you're going to come back, you're not going to have any microbes left because there was nothing for them to feed on. And you can't then start feeding the digester and hope you're going to get biogas the next day. It takes 30 days for the process to start. So if you realize today you haven't got biogas, it's because you didn't feed it 6 weeks ago, not because you didn't feed it yesterday, right? Which is, sometimes, you get the call, ooh, my digester, we haven't got any gas. So there's something wrong with your system. So I said, when did you last feed it? No, we fed it last week. I said, but did you feed it 4 weeks ago? Oh, yeah, I was in Durban 4 weeks ago. Yeah, so, okay, well, that's the reason why you haven't got biogas.
Do you have auto monitors that would tell you this is what's happening now, that you can see what's
on your big commercial digesters, everything is controlled. On the big commercial digesters, you can run the entire plant off your cell phone. It's fully automated. But on a small scale, it's an experience.
And energy you would have acquired from this, if then it's not used, is it entirely stored until it is consumed, or do then is there a chance of losing it if it's not used within a certain period of time? Does it get completely stored?
Good question. You've got, normally digesters work on a continuous basis. So if you chuck in 100 liters of slurry into your digester now, or on a day, 100 liters will flow out on the other side. So it's only the solid content in your liquid that gets consumed by your microbes. So that's one of the biggest, what people neglect to understand fully or comprehend fully and make provision for it, is that, if you put 100 liters in or a ton in on this side, it doesn't disappear. You still get a ton coming out on the other side. You've just removed most of your solids that's been eaten by the microbes. So you can't, it's not biogas is very good. It's a brilliant system, but it doesn't, just makes things disappear. That would have been great as well. So whatever you put in on one day, you got to either let it run out on the other day or pump it out or on the other side. So that was one of your questions. The other one, it'll come back to me in a second. But yeah, just on that point as well, whatever the consistency of the material going into your digester, I always say as a rule of thumb, it's got to be in the form of a runny porridge. The finer it is, and it's got to have enough liquid in it that you can pour it, that it can run. That's just as a rule of thumb. It needs the water, diluted by water. So if you've got you're in the middle of nowhere and you've got a chicken farm that needs about a 1 to 4 water, then you've got a serious challenge, because there's normally not that quantity of, you've got 1 million chickens or whatever the case might be, and you use mega liters of water. Then it's a challenge to put in a digester, because you've got to dilute it. So and the reason why you've got to break it down is, if you take argument's sake, if you take a cauliflower and you chuck that into the digester, you've got only a limited surface area where the microbes can start eating. You put that thing through a liquidizer and it breaks it down. You increase the surface area by 10,000. So the microbes have got a much better chance, or more opportunities, more surface area to actually do their work. So if you put a whole cauliflower in, it might stay in your digester for 60 days. If you put it through a liquidizer and you put it in, it might stay there for 5 days before it's fully consumed.
Sorry, can I add
Yeah,
two
sure.
questions to that? So how long does the waste need to be in the digester for you to then say, we've got all the biogas we need? And how do you also know that it cannot produce any more biogas and it needs to be taken out as a compost?
The time that it takes to decompose is 100% dependent on the type of material. So if you've got cellulose base like grass or something, or straw, that's going to take a long time to decompose. But if you've got processed food waste, you know, the grass might need 60 days to decompose. But food waste, maybe 10 days to fully be digested rather than decompose.
Food in, after 10 days, I will be getting gas. But how long does it need to stay in there to keep getting gas before I then take it out?
Now, after 10, say the type of food requires a retention time of 10 days. If you close the system, if you chuck the food in and there's already microbes in there, and you shut the system, you close the system down, you will start producing biogas immediately or within a day or two, and your biogas production will go up, you know, in a linear curve. That flattens out. So after 10 days, typically you will get most of your biogas, say 80% of your biogas out. Right? You will still get, if you want to get the other 20% of it, so that you get every single liter of biogas out of your potential material, you probably need to put it in there for 100 days. But there's a financial viability point that you normally work on about getting about 80% out of it. And that's where literature will say, listen, typically food waste, you need 10 days retention time. Grass waste, 90 days, or whatever the case might be. But that is to reach the 80% point. It's not to reach the 100% point. If you want to get 100% out, you'll have to make a digester 3 times the size. And that's not financially, that doesn't make financial sense to do that. So you will, if your biogas digester starts off with, if you kickstart it with manure, you're within the first day or two, you're going to slowly start producing gas, primarily CO2. Your methane percentage will be very low. And as the process progresses, your methane percentage will start rising until it reaches around about 60%. Again, very much dependent on what type of material you've got. But once you've got the systems going, you will be putting in the design quantity on a daily basis. You'll get the same quantity digested material coming out on the other side, and you will have a fairly average biogas production, because it will then be a continuous process. There's a few guys that still do batch digesting, but it's not really practical, where you've got a huge big bladder, and you put the material in, seal it in there, and you take the gas out until it's done, and then empty the whole bladder again. But financially, it makes a lot more sense to do it on a continuous basis, for small scale as well as large scale. Okay. All right. Let's just get back. We spoke about manure. Obviously, any type of manure is very good. The only one that's got a bit of a challenge is chicken manure, because chicken manure has got a very high ammonia content in it. So it's got a tendency to acidify if you don't supplement it or co-digest with something else. You probably need about 30% of organic material with your chicken manure just to buffer the ammoniac level. We've got quite a few digesters that's been built on pig manure. There was a company, or there is a company that was quite active in the pig industry, and it built a lagoon type digester, which is literally just a huge big dam, and you pull a sail over it. It's as simple as that. And instead of all that methane escaping into the atmosphere, it just goes into the sail. A colleague, one of the guys about 5 years ago, first guy, it was in KwaZulu-Natal, oh boy, that did biogas on a bladder, on a batch type digester. And he went to a farmer, and the farmer said, no, man, this biogas, I don't believe it, it doesn't work. He's got a cow, he's got a dairy, and he put all his manure, went just into a pit. So the guy said, listen, have you got some waste pipe and a sail? Give me some, the normal waste pipe, 110 mil, drainage pipes. He made a square out of it, covered it with a sail, chucked it on that pond, and within an hour, that sail was standing with biogas. He tapped it off, and he lit it for the farmer. I mean, that's how practical it can be. No? So the most simplest form of a digester, larger scale digester, is what they refer to as a lagoon digester. It's literally for the pig farmers. All their manure gets washed out into dams. And the crudest form, you can literally just dig a trench right around the dam, cover it with a sail, bury the trench in the ground so that the gas can't escape, and you tap off the gas. I mean, it can really be as simple as that. And we've got the biggest plant at the moment to date that is on the cards. It's in Bronkhorstspruit. It's a 3 megawatt plant. It's massive. It's a 140 million rand project, based on the primary feedstock is from a cattle feedlot. They've got about 25,000 cattle standing in one spot. So that's a very good source of feedstock for your digester. But that's a massive, big installation based on a feedlot basis. And manure. Agricultural, obviously any kind of food waste. And in Europe, you'll find that probably 90% of their digesters in Germany runs on silage. So they grow grains, they ensilage it, and that gets fed digester. So that's obviously quite controversial because it's a food that now gets used for energy. So that's a controversial topic in any country. But also in South Africa, I mean, we've done a proposal for a fruit packaging plant. Fantastic project. You know, instead of chucking and trucking all of their skins and peels and fruit, chucking it away, goes into a digester. So there's massive potential there. I'm busy with a project with the Sugarcane Association down in Durban to use their cane tops that gets burnt on the fields at the moment, to use that as a source for biogas. And then on the commercial side, you know, any industry that produces organic waste can be a potential for biogas digester. Abattoirs, as I mentioned, cheese factories, you use the whey as your organic feedstock for your digester. Breweries, as I mentioned, SA Breweries, there's a wine estate down in Cape Town that's already doing biogas from the wine effluent, you know, and fruit packaging plants, etc., etc. So there's a really quite a wide spectrum of industry that can benefit from biogas digesters. I put together this slide when I did a presentation to the dairy farmers, and I said, listen, you guys think that milk is your primary source of income from your cow. You could produce 3,000 rand value a year out of one cow, right? By just utilizing its manure through a digester system. You know, your electricity, your heat, your solids that you can do as a compost, and you can take the liquid out of it as well. So yeah, so there's quite a bit of benefit in the cow apart from just the milk that you're producing. Okay, the next section, I'm going to talk a bit about the different types of designs of digesters, just to give you a bit of an idea of what the things actually physically look like on site. So we're going to look at first at some domestic digesters, and then some more industrial type of digesters. Here is what if you Google biogas, you're typically going to see what they refer to as a fixed dome digester. This is what's been built in China, where they got millions and millions of digesters, built out of brick and mortar, and it's built as an igloo structure. So you put your manure in there. You will build an inlet manhole on the one side and an outlet manhole like this as well. There's an inlet and an outlet manhole, and the reason why you've got a 3-compartment system is to maintain to prevent any oxygen from going into your main tank. So you've got your inlet manhole that's got a pipe that connects to your main digester below liquid level. And below liquid level, there's a pipe that comes out into your outlet manhole again. So it works on the same principle. If you've got a hose pipe and you put it full of water, fill it up with water, and you put a cup of water on the side, it's simply going to push out a cup of water out on that side. So most digesters work on the same principle. So you will put into the inlet, or this is the outlet rather, on the inlet, you will put your material in. It will progress through your digester, eventually come into your outlet, and your outlet pipe level will determine the level in your digester itself. So if you put in 100 liters there, it simply raise the water level until 100 liters has run out of your outlet again. If you've got an area where you've got a bit of a gradient, it can by gravity feed out again, then you don't have to pump anything. This is a digester I installed in Northwest Province. The ground is flat there, there's no gradient there. So they will put a bucket of slurry, manure slurry and food waste in on that side, and they will take the same bucket and remove the same quantity out on this side and put it onto their vegetables. If they don't do that, the whole digester volume, whether it's that one or this one, the whole digester volume will be filled with liquid, and there will be no space for the biogas to accumulate.
How much is the cost of these?
It very much depends. This is the biobag solution is probably your cheapest. Anything from, it comes in a kit form, or you can install that. You can probably install that for about 15,000 rand. Your fixed dome digester is probably about double that cost, if not more. It depends on, there's an in situ cast concrete digester that's going to cost even more. So it depends on, it depends on your application, where it is, your access to material, what kind of feedstock you've got. So that's one of the biggest challenges around biogas, is to decide on what system you want to use, what type of job creation you want to do, how much skills transfer you want to do. Ideally, if we're talking about rural, which we're talking about now, you want to get the community involved as much as you possibly can, and let them install and train them how to build and operate the digesters, which is a little bit different from your big commercial digester. So this is just typically 3 different types. This is called a biobag, or a soft balloon type digester. That's what the majority of digesters in the world is built using a brick dome structure. I'm not too keen on this structure. I actually don't build any of them, and I haven't built any of them, purely for the reason that the minute you build that kind of structure in the ground, you've got a brick and mortar structure. If there's some settlement taking place, it's going to crack. If you've got a crack, you've got gas under pressure, you've got a maintenance issue. So we had last year we had a national biogas conference sponsored by the Department of Energy and the Development Bank of South Africa, and we were privileged enough to be able to invite a speaker from India, Dr. Kave, old buddy in his 60s. He's got vast experience of biogas, and he said that of the 12 million digesters that they built in India were built using the brick dome system. He says only a quarter to a third to a quarter of them are still operational because of maintenance issue. If that thing cracks, to fix it up again is a major challenge. That's why I'm personally not particularly. It works very well. There's no question about it. But if it's not maintained, or there is a problem with it, it's extremely difficult to get that thing going again. So personally, from my side, I do the biobag system, or I do the in situ. Instead of doing it out of brick and mortar, we use concrete and a mold, and we build an in situ cast concrete digester. Then there's two digesters, rotor molded digesters, that's been developed in South Africa. One is done by a company down in Cape Town called Agama. It's a Biogas Pro. It's also a rotor molded system. And then we've got my esteemed colleague on my, where was he? On my right hand side. There he's at the back. That developed a brilliant system called the Little Green Monster. It's as Wally mentioned, it's on the small side, but perfectly capable of in a small domestic application, uniquely designed in South Africa, very innovative. So these are typical 2 products that is available in South Africa, but it's rotor molded. So what's nice about that, obviously, is that you can put it on the back of a bakkie, you can drive it, you can drop it in the ground, you can install it. Whereas with the previous digesters, there's a lot of more manual labor involved. But any one of the 5, is primarily the ones that I've shown now is what will be applicable on a smaller scale, rural type of application. Oh, there's just another photograph. This is in Kenya. I think in Vietnam, they're very keen on their biobags as well. You can literally go to a hardware in Vietnam, and you can go and buy a already welded tube of plastic. It's a cylinder. You buy it. And all you do is you seal it around at the ends, and you put a pipe in both ends, you seal it around the pipe, let it point out of the ground. There's your digester. Exactly what they've done over here. This is just was one of my first bigger balloon digesters we installed at a piggery in Tarleton. These are 250 cubic meter bags working on pig manure. It works very well. It's not heated, it's not mixed, so it's very basic. But as long as you maintain the anaerobic conditions, you will digest and you will generate biogas. Okay, that's just another photograph of how you install it. This is a local cooperative in Northwest Province. They got funding from the UN, and they got money to buy. I was just a technology provider here, and we provided them the biobag in a kit form. So this is exactly what will be installed at the school. We'll finish it off a little bit nicer than this. But the principle, remains the same. You literally just dig a trench, you build an inlet and an outlet. In all communities throughout South Africa, they've got a bricklayer. So it's the only skill that you really require is a bit of bricklaying, and you've got to plaster it, and you literally just drop the bag in, connect it to your inlet and outlet, and got you. So what can you do on a small scale? What can you do with the biogas? These photographs are taken in my house. I haven't bought LPG gas to cook on for the past 5 years. We use the biogas produced from our digester for cooking purposes, primarily for cooking purposes. But I've also got a little 700-watt generator. So if Eskom goes down, at least I can watch my favorite TV programs and just run the TV. You've got lights, it's just a little gas light that runs on biogas. We've got a hot water geyser that runs on biogas. And all of these products I bring in from China. It's not been made. There's not enough big enough market in South Africa to locally produce yet. We're working on that one. I'm motivating the government sectors to give us some funding to develop this. So these, for two reasons. China, they've got 70 million digesters. So they've got a well-established market for small scale. You cannot buy any of these appliances in Germany. Although numbers-wise, commercial numbers-wise, they've got the most digesters because they simply don't use the biogas at all for domestic applications. They use all of it to convert it into electricity and selling it back into the grid. That makes a lot more sense. So these components, it's already designed to run on biogas. If you want to take a normal LPG gas stove, you can adjust it or amend it, or not amend it, to adjust the nozzle openings in order for it to run on biogas by simply opening your nozzle sizes to allow more biogas to come through and regulate of the number of digesters out there in the world that will be used for cooking purposes. Yes, Conan?
Can you possibly mention how much gas the school is currently using and what we're hoping to offset?
Yeah, I've got what you can do is we will be producing at the school, we'll probably be producing about 3 to 4 cubic meters of biogas per day. 1 cubic meter equates to about half a kg of LPG gas. So that's where we're talking. It depends on the on how much food waste. I think they said they produced about. Help me, guys. What was it at the school? About 100 liters, yeah. So we produce about, in the region of about 7 cubic meters of biogas at the school, if they've got that 70 kgs going into it. About 10 kgs, 10 to 15 kgs of food waste will give you 1 cubic meter of biogas if the system is up and running. So yeah, so to give you numbers, if you start talking about numbers, a cubic meter, to produce a cubic meter of biogas, I'm gonna hit you with a couple of numbers here. To produce a cubic meter of biogas, which will give you 1 hour's cooking time on a 2-plate stove, 1 cubic meter of biogas, you need the raw sewage of about 15 people. 1.5. 15 to 20, depends on the size of the person. Or, yeah, some of it more full, I didn't say that. So 1 cubic meter is from about 15 people, or 3 cows. 3 cows manure production will give you 2 to 3 cows. If you've got a very sophisticated system and it's heated and mixed, 1 cow will give you a cubic meter of biogas. Or 7 horses, or 15 pigs, or 150 chickens, etc., etc. That will all relate more or less back to 1 cubic meter. But there's a lot of variables that will play a role. Yes? No.
But that's different to LPG gas, because LPG is compressed in a cylinder.
Not when you use it. When you use the gas from the LP, it goes past the regulator. And when it comes out of the regulator, you can actually, the pressure on that is that you can put your thumb on it. So it's got about 2, 3, same too. We're actually getting more, typically we will get more pressure out of if that bio bag is full, it'll give you probably about 7, 8 kPa of pressure. The pressure that comes post-regulator from your LPG gas cylinder is about 3 kPa. And that's all you need. As long as it's constant at about 2 or 3 kPa, you will run your appliances.
Does your bag then have to be in the vicinity of where you're going to be consuming the gas?
Ideally, you want to do it, but not because you can't transfer. But not because you can't transfer the gas. Johannesburg get some of our biogas from Mozambique. You can pump your biogas or your gas as far as you want. It's a distance. As long as you've got pressure, and you can pressurize it. Then it's not a problem. You can take it as far as you want. So the reason why you would like it, it's purely from a practical point of view that you want your digester as close as possible. Then you can save cost on your line. If it gets too far, the bio bag does, if it's full, it has got pressure. But once it starts deflating, it's got no pressure on it. So that's the nice thing about the bio bag system, is you can simply put 2 old car tires on top of the bag. Gives you enough pressure to push the gas out. Whereas if you got your fixed dome digester, you have to actually suck the gas out in order to. That's why sometimes you get a floating dome, like you saw old John Fry with his two drums. That drum actually floats and it compresses the gas, so it floats on the gas. So that will automatically pressurize the gas when it comes out. So there's various ways that you can pressurize it. Ideally, you want to do it automatically, and you don't need a pump. That's one of the reasons why I like the systems that I support, because you don't need a pump. You can actually, with 2 tires, you can do the same thing. But yeah, you need at 2 or 3 kPa. To answer your question, because you can compress gas. If you want to ride your car on gas, you have to put it into a cylinder. If you use about 10 bars compressor, you can probably get about 2 kilograms of biogas equivalent into a 40 kg cylinder, only 2. If you want to get 48 kilograms into a 48 kilogram cylinder, you've got to compress your gas by 180 bars, which requires a massive big plant, because it only liquefies at minus 40 degrees, so it's a much bigger challenge to get it compressed. That's why you only really will compress it if it's a massive big plant and you want to do vehicular biogas. I always say, nearly 95% of the cases, the more practical is you don't need to compress it. You use it as it comes out. You don't even have to take the CO2 out. The generators that you get in your stoves runs on the biogas as it is produced with the CO2 that's in it. You can scrub the CO2 out. That's another process. And then you end up with practically 98% methane, which has then obviously got a much higher calorific value. It's a much higher combustibility. So if you want to run your car, it's better to run it out on compressed biogas rather than just the biogas that still contains the CO2 in it.
Do you literally just open the tap, or is there some kind of regulator that comes out of this bag?
No, you just got a valve, just free flowing. It's basic. That's what I like about it. You don't need pumps and all kinds of stuff, typically for basic rural application.
From a return of investment, in the case of your house, how feasible, how long it takes to
pay it off.
Comparing to LPG, if you used natural gas to,
Yeah. No, it's a very good question, and it's a question that gets asked always. And that's where the biggest challenge comes in with biogas. Because you've got so many variables that will determine how much biogas you're actually producing. It's the type of design of system that you got. Is it heated? Is it mixed? Are you getting the full 80% out after 20 days, or are you only getting 60% out? So all of those, and the type of, is it a fatty-based material that you've got? Is it an abattoir waste, or is it a silage-based, or is it away from a factory? All of those will determine the financial viability, because that will determine the type of plant, the size of plant, and whether you want to invest in mixing and heating as well. So I'm not trying to dodge your question by any means, but it's extremely difficult to give you a straight answer.
in your house?
In my house, that's what I'm getting to. In my house, it cost about 40,000 Rand to install my digester. I have got sufficient material externally to put about 100 cubic meters of slurry into my digester every day. I paid that off in about 18 months, right? But that is because I've got enough feedstock to put into it. If you got less, it's going to take you 3 years or 4 years to pay it back if you just working it on replacing LPG gas. But if you can get the added benefit from, if you're running a small generator, you can capture the heat, there's that value. If you've got, there's value in the compost that you don't have to buy compost now. So there's a lot of factors that will eventually determine the complete financial viability of your investment. On a big commercial digester, you're talking about a payback of about 7-8 years on your big commercial digesters, depending on whether you get a grant or a subsidy or whatever the case might be. Obviously, the minute you get a grant and a subsidy, it makes the returns that much more attractive. But yeah, it is a very, very difficult question to answer because there's no generic solution in biogas. You literally, even if it's a small rural application, you've got to go and see, for instance, I'll give you an example. If you go to a guy and he's got, city pigs, has he got somebody there standing with a hose pipe washing those pigsties every day? Or does he go with a squeegee and picks up the solid manure that goes into the digester? Because that will determine how much solid material per volume are you putting into your digester. If you're standing there with a hose pipe, it dilutes, so you only got about 3% solids going into your digester. Where if you pick it up with a squeegee and pick it up in a wheelbarrow, you probably end up with 10 or 12% solids in your material going in. So in the latter case, you're going to get much more biogas out of your digester than compared to where there's only 3% in it. So there's a lot of factors that will determine the viability of it. And that's probably one of the biggest challenges we have in the biogas industry, is to have the knowledge and understanding and the experience to be able to do that calculation for your client. Because what we found is that there's a lot of guys, because we haven't got biogas technology, we had it in 1950, but because we haven't got the technology or the experienced personnel in South Africa or companies that have got the experience, it's all based on theoretical experience. And then you get a European company that joins with a local company to promote the biogas projects, but they bring European standards, conditions, and experience and apply it in South Africa, and we know that doesn't work. Because for that very reason, if you come from Denmark, that's happened, it's a real case. They got a company coming from Denmark to design a plant on a pig farm here and said they're going to be able to produce at least 1 megawatt of electricity. They end up producing about 200 kilowatts of electricity. Because in Europe, their manure management is fantastic. They've got very little water. They managed to get all their manure out without the use of water. So they end up with 8-9% solids in their waste going into the digester. Here in South Africa, we got somebody standing there with a hose pipe, washing the whole day. They got 2% solids in there. So that whole system didn't produce 1 megawatt. So the whole project was based on a certain return based on the amount of cubic meters of biogas they will get out of their tons of waste, and it never materialized. So that's the challenge one has. Okay. Let's see where we go from here. Okay, yeah, I said I'll show you a slide of what can typically happen. We're busy with a very exciting rural-based project based on a digester. If you go into a rural community and you put in a digester, they take their waste from their cattle or kitchen waste or whatever they can, put it into the digester. Out of the digester comes two things, compost and biogas. You understand that by now. Now, if you make that system bigger and you put up a tunnel, all right, and or a piggery or a chicken unit, and you make that the financial income for this project, it produces the digestate out of the tunnel, the waste out of the tunnel, or out of the chicken farm, or whatever the case might be, plus with other waste from the house and whatever animals they've got, goes into a digester. That produces the financial viability for the project. Job creation, permanent income. You've got a digester that gives you the compost that goes back into the greenhouse. And you take the actual people the owners of the project or the beneficiaries, they get the benefit of all the biogas coming out that they can then use for cooking purposes or electricity or whatever the case. Depends on how big the system is. But from a point of a sustainable rural project, the biggest need we have in South Africa is job creation in our rural communities, food security in our rural communities, energy provision in our rural communities. When you develop this project to its full extent, we can address most of that, if not all of those challenges that we face in our rural communities. So watch this space. Hopefully when we talk again, we will have one of our pilot projects up and running. That actually encompasses everything we're talking about here.
Excuse me.
Yeah.
When you do that manure, you put it in the digester. Now, what about the microbes? I'm talking about stuff like E. coli, salmonella. Would that be destroyed in the digester before you put it in as compost now, or what are we talking?
Very good question. What happens in the digester, you will probably destroy, depending again on the variables that we've now understand of, a certain percentage of your harmful pathogens will be removed or destroyed in the anaerobic process. But remember, it's not a full digestion process. You have only got anaerobic digestion. You still need aerobic digestions as well. And so if you can take this material that comes out there and you put it through a wetlands and you get aerobic digestion that takes place as well, you will remove some more of your harmful elements in your manure. The biggest challenge comes, but it won't remove all. So to answer your question, it will not kill salmonella, right? Especially if it's human sewage that goes into the system. Because of all the antibiotics and all the gemors that we're drinking as humans, that all, some of that will go through the system. So you will typically, if you want to, if your digester is fed with human sewage as well as other material, or exclusively on human manure, you will not use it directly on your plants because you will contaminate it. You can use that and put it separately and help to produce compost and work that into your ground and fertilize your ground and then plant material on it. That could be acceptable. But again, it needs proper investigation to understand whether that's a healthy living rural community or the sewage that goes in there, or is it the sewage that comes from an AIDS clinic? Because it will vastly different the quality and the composition of the material going in. So if you're using it for directly on your own vegetables, especially leafy, you will not, as from a safety point of view, it doesn't matter what you put into your digester, you will typically not spray it on your edible leafy plants, just from a safety point of view. Some of that you will be able to, but just as a golden rule of thumb, you use it to fertilize your soil. You don't spray it on top of your plants. Specifically for that reason, that you don't know what has been destroyed and what has not been destroyed. So that part of it needs careful study to understand exactly the composition of your compost that comes out of the system, to make sure that you do not contaminate the vegetables that go. If it's food waste coming out, if it's only food waste coming in there, like we will have at the school, there's only food waste coming in there, that is not a problem. It's not a problem at all. That you can even spray. If you take the liquid component, you can spray it on tomatoes and stuff. There's no problem with that.
This is exactly the reason why we originally considered that little green monster, the picture of the two digesters, the one on the right-hand side that looked like a green barrel, and we originally considered putting that in the ground and breaking the sewage line and using the human sewage to do that. And this is why the whole project got turned on its head when we started consulting with Mark, is to rather have the bio-bag solution, which is then only food waste or vegetable scrap waste from the veggie garden, primarily so we get away from human pathogens, and so that the digester is recoverable to use as a liquid fertilizer on the veggie gardens. So everything is humanly, consumably organic. We're not playing around with sewage anymore.
Yeah, well, we must also, we get a bit fussy in our modern times. But if you go back in, the early 20th century and so on, your biggest compost came from human waste. Human sewage was used throughout the ages as compost, perfect compost. It's only in the past, 100 years when we started consuming all kinds of funny gogas and chemicals and all kinds of stuff that has really affected the quality of the manure that we're producing. Okay, where are we? Okay, yeah, just a couple of, we talk about rural projects. What are the basic advantages? We're obviously replacing any other source of energy, whether it's electricity, LPG, paraffin, wood, or any fossil fuels. We're replacing that with biogas. That's the advantage. You eliminate smoke and toxic fumes in the house. It's a big problem in our rural communities where the light fires inside the house, whether it's a primer stove or whether it's the fumes from burning wood, especially green wood and stuff. But the biogas can be used to run lights and provide hot water. Hot water consumes quite a bit. In rural applications, they will typically get hot water from boiling it on the stove or on the fire. It makes a lot more sense if you're doing a community upliftment program to provide the hot water side of it, provided with a solar geyser. It makes a lot more sense. And that's where it's very seldom a single technology that will provide all the answers. It's a combination that will give you the best solution to actually provide in an entity going off the grid. Obviously, it can be used to generate electricity. We know it turns environmentally hazardous waste into compost. Job opportunities, skills transfer, we've spoken about it. We've spoken about carbon mitigation on a large scales. And obviously, if you start talking about rural, there's job opportunities, and the biggest need is for youth and women in rural communities. And biogas can easily utilize both of those sectors of our community. And the minute you start growing vegetables because of the compost, it makes it, you add to food security. So you really, I can't understand why we're not building more digesters. I mean, it just makes so much sense. Okay. Just a couple of slides on more commercial size of digesters. This is typically what's referred to as a plug flow digester. It's literally one of my big balloons. It's simply what it is. This is in America, mostly manure based, and it works exactly on the same. This is why it's called a plug flow. It's simple because the consistency of especially these digesters are typically used for cattle manure, for cow manure. Because of the consistency of cattle manure, it's got a much more tacky, sticky consistency. So that's why if you put in a day's manure into the system, it literally, it forms a plug. Because it sticks together, it forms a plug right at the start, at the inlet. So the next day's production will push that plug out a little bit further. And eventually that plug will steadily progress through the digester, so the plug flows through the digester. So that's why it's referred to as a plug flow digester, but it's very specific for cattle manure, and sometimes it's been used for pig manure as well. Very simple, very straightforward. It doesn't need a lot of sophisticated pumping and monitoring equipment. Traditionally, it's not heated or mixed. It literally just progresses through the digester. This is probably, it's called a CSTR, or continuously stirred tank reactor. This is what's built mostly in Europe. It's a huge big tank, it's heated, and it's mixed. And it's got a dome on the top that captures the biogas. That will get tapped off. Why you want to mix it is to make sure that the microbes are uniformly distributed and do their works as effectively as possible. These little pipes on the side is typically hot water pipes running through the inside of the digester. You get your heat from your generator. You will pump back into the heating to heat your digester to maintain it at 37 degrees. And that is typically the majority of large commercial digesters are built this way. I'll show you a photograph a little bit later of a big tank that we've just completed at the abattoir that works exactly on this principle. So it's a closed loop system here. So you've got your gas that's get produced, runs a generator. The heat from the generator goes back and heat the digester again. And the digester goes out, is discharged, and goes to compost, as we said. But this is probably your most common type of digester used for commercial applications. Yes, just two examples. This is a digester, exactly what I just showed, a digester that was built in Jan Kempdorp by Eibert. So it runs, I think it's about a 150 kilowatt generator that runs there. It's also run on abattoir waste. This is a photograph of the digester we're building. It's got its dome on our old photograph. It's about 1,800 cubic meters tank that's being built at the abattoir there in Springs. So yeah, no, this is just examples of digesters that's being built on a commercial scale in South Africa already. This is just a photograph of a really, the 3 megawatt plant I mentioned earlier on at Bronkhorstspruit will look very similar to the setup over here. This is a big 3 megawatt plant in Denmark. So you've got your, that's your gas storage over there. You've got your big digesters, you've got your digestate storage tanks over there, and your generator is housed over there. So that's typically what will happen. And you will see in some of the photographs, these guys come in and the trucks lines up, 5, 6, 7 big tanker trucks lines up to come and collect the digestate to go onto the agricultural fields as compost. This is just I'm not going to spend too much time on here. That's called an upflow anaerobic sludge blanket reactor. That's typically what you will use that if you got less than 2% solids in your material that goes in. This is what was built at the South African breweries, where they got less than 2% solids in it. So the material, there's millions and millions of ceramic balls or whatever, small pebbles in the bottom of the digester that gives a surface area for the microbes to adhere to, and you literally force your feedstock water from the bottom goes through, the microbes stomps all the food stock, the biogas gets captured and pumped off. This will typically take anything from 18 to 48 hours retention time. It's very, very, very quick, very efficient. So the system is much smaller than your typical big tank reactor, where we're talking about 30, 40 day retention time. So they're quite efficient. It works very well, but very specific application. I did a study for municipalities to look at the waste to energy potential at municipalities in South Africa. These digesters, Uppington, Potch, Newcastle, they were all built in 1980, late 1970s and 1980s. This is a typical digester. So next time you drive past a wastewater treatment plant and you see these tanks, that's a digester. That's what it is. Most of these are actually open at the top. They did not capture the biogas. They weren't interested in the biogas side of the digester. They were more interested in using it to reduce the pathogens and reduce the volume of solids that in the manure. When I was in Uppington, the guy told me that about 10 years ago, apparently there's one of the maintenance guys that just started at the plant. He climbed up and stood at the top of the digester and enjoyed the view and lit a cigarette. They found his body 3 kilometers away, further on. So yeah, it can be very dangerous. One has got to be very careful with combustible gas. It is a combustible gas. One has got to be very careful. Typically, these big digesters were mixed. They've got a mixer right on the top that either mixes or it simply pushes the water down, pumps it out, and it circulates. And that's how they mix the digesters. But yeah, so there's, as I said, a couple of hundred of these digesters at various municipalities in South Africa. There's a comments. This is just typically what a generator will look like, a biogas generator. You obviously got your main engine. This whole big silver system you see on the top is just to capture the heat from the engine, and they create hot water. You can capture the heat from the exhaust gases as well. So that will just increase the efficiency. You normally get electrical efficiency, anything between 32 to 42% electrical efficiency. If you go for a big Jenbacher top of the range, you'll probably get about 42% efficiency. On something that comes out of China, you probably get about 32%. But then, for typically what we spent on the digester of the generator that we installed at the abattoir, it was about a 5 million rand generator. We could get it for 3 million rand from China. The one we installed has got about 38, 39% efficiency. From China, we could spend 2.5, 3 million rand and we'll get 30% efficiency. Or we could spend 6 million rand or 6.5 million rand and buy one from Jenbacher. So it all varies on what you can, and that will come back to your question as well. That will determine is another factor that will determine your financial viability as well. Whether you spend 3 million rand and get 30% electricity efficiency, or whether it justifies spending more money on a more sophisticated and high efficiency generator. Okay, I think we're nearly done. Just this is just a study that was done by UCT for the Wastewater Research Council. It was done about 2-3 years ago, just to get an idea of what is the potential for biogas generated electricity in South Africa. And they came up with 2.6 gigawatts of electricity from biogas. Now, if you look at them, I think the whole renewable energy sector, Wally, correct me if I'm wrong, I think it's about 9 gigawatts that the target for, or 10 gigawatts target for all renewables in South Africa. And biogas didn't even feature on their planning until recently. But we can probably, the entire target of 10 gigawatts we can do with biogas, we can do about 25-30% of that. And this was not even a fully comprehensive study. I just did a quick calculation when I did a presentation to the bank. We're talking about a 10 billion rand investment without even trying. So it really could make a major contribution, not just from an environmental point of view, from a renewable energy point of view, from a carbon mitigation, etc. Actually, just purely from an investment point of view for South Africa, it makes a lot of sense to look at biogas. Just a couple of pointers here. Why, I asked the question before, why has biogas not been developed up to now? One of the main reasons why is because we were spoiled with electricity. We weren't interested. I mean, if somebody said, put up a solar geyser 5 years ago, you would have laughed at him. Why would I? I just use electricity. Now it becomes a real factor to consider solar geyser as a viable option. But in the meantime, what we've done in the past couple of years, we created an association. We created a national platform where we got all the government departments sitting around the table, plus the Escoms, the IDCs, the SANEDIs, the CSIRs, all of them sitting around at one table to promote biogas. There's a conference. If you guys, any of you that are interested in to find out a little bit more about biogas, there's another. We are having another conference on the 4th and the 5th of November this year, sponsored by the Department of Energy. There's a lot of awareness that we've created now amongst government departments. The challenge is there's not an understanding yet. The gap between understanding and awareness is still quite vast, and we're trying to narrow that gap. Challenges probably in biogas is lack of experience. As I mentioned, there's very few experienced people in South Africa, companies in South Africa. There's a lack of understanding of all the multiple benefits of biogas. Everybody thinks biogas is electricity, and that's where it ends. There's the processes that it's got to go through as far as licenses and so forth is very challenging, because biogas, there's no frame of reference for the specific government departments to approve biogas projects. We've got to learn and go through the process. We've got a lot of foreign companies coming in at the moment looking at, because the European market is quite satisfied at this point in time, or saturated rather. And we've got companies coming in from overseas, but with overseas know-how and technology. And obviously funding is always an issue, but that should become easier the more projects that comes out. I think that's about the end of the presentation. I'll skip that one and go to that one. Okay, but yeah, if there's any more questions, I hope I've given you a little bit of an understanding of the broader picture of where biogas comes from, what can be done, what we can do, what benefits it has of promoting a project like the one that you guys are doing at the school. It's good work, and it's a very exciting, and it's not even a technology because it's naturally occurring. It's a very interesting field to be in, biogas, because it literally is probably the most natural way to generate electricity.
Education, social justice, environment.